And the one that people kept talking about was number 16. So I thought we could do that one first. Does that sound reasonable? 16? Okay. So it says, at what instant will the particle start to reverse its direction? What function do we talk about the direction that a particle is moving? What function gives us that? Velocity. So we're going to have to find the function for velocity. They gave us the position function. So what do we need to do? Take the derivative. It is a lovely rational function. So what do we have to do? The quotient rule, or you can do a product rule and use the -1. So what would you guys rather do, product rule or quotient rule? Quotient rule? All right, so we got low, d high, minus high, d low, divided by low squared. So t squared plus 5 minus 2t squared. Okay. So I knew that the function that tells me the different directions is a velocity function. But once I have the velocity function, how do I know which direction it's going? Okay. And how do I know which numbers go on the number line? Okay. And if I have a fraction, how do I know where a fraction equals 0? The top. So I'm not so much worried about the bottom equaling 0. I'm worried about the top equaling 0. Okay. So in a fraction, we know that the fraction equals 0 when the top is 0. 0 divided by 5 is 0. 0 divided by 10 is 0. 0 divided by 100 is 0. So if I can make the top equal 0, then the whole fraction is going to 0 out. So I'm going to say negative t squared plus 5 equals 0. And then what should I do? I'm solving for t. How do I solve for t? You can factor it. Take out a GCF of a negative and get t squared minus 5. And then I would just factor using difference of squares. Even though it's not a perfect square, you can still do it. I like having my stuff in factored form because I like being able to plug numbers into factored form. So I would do t plus root 5 and t minus root 5 if it was me, because that's easy to plug numbers into. Okay. So our solutions are what? We got negative root 5, we got positive root 5. And then based on the problem, which of those solutions is appropriate to use? Say it again. only the positive one, because this says t is greater than or equal to 0. We're not going back in time, which I feel comfortable with. So we're starting our sign chart with 0, and we're going to go to root 5. I'm sure it changes directions at root 5. That's probably what happens, but I can go ahead and do my sign chart just to verify and make sure so I feel better about my answer. Okay. What's a number that's smaller than root 5? You can use 2. You can use 1 if you feel better about plugging that in, if that's a little bit easier to plug in. And then for a number that's bigger than root 5, I'm just going to use 100 so that I really know it's bigger, because that's easy to plug in. I don't know. Okay, so I've got a negative sign in the front. 1 plus root 5 is positive. 1 minus root 5 is negative. And so overall, what's happening here? Negative, so I'm going to just put negative right there. Okay. 100, so we've got a negative in the front. Oh, positive. Woo. Sorry. Reagan, we were on the same team there. We were feeling it. We were both very confident. We were confident in our typo. It was a typo. It was just a typo. Okay. So we got our negative. Now we got 100 plus root 5, which is definitely positive. 100 minus root 5, which is definitely positive. And then what's this one? Negative, no typo here. Okay. So the particle was moving to the right and then switched directions to the left, or it was moving up and then switched directions to down. But it switched directions. Okay. So we can say it reversed directions at time equals root 5 is where it switched directions for sure. And then if they're asking the question, where was it at that instant? Which function do we use to describe where it was? The first one, position. If you want to know what position it was at a specific time, use the position function. If you want to know what direction it's moving and how fast it's moving that direction, then you use the velocity function. But for the position, use the position function. Okay, so now we're going to say s of square root 5 is square root 5 over square root 5 squared plus 5, and looks like square root 5 over 10, and I'm just going to call that good because, it's not calculator active, so we're done. So we're taking those typical position, velocity, acceleration problems. They call them PVA, position, velocity, acceleration, or they can call them rectilinear motion. So those types of problems, they just took that type of problem, they amped it up a little bit. They made you interpret a little bit more to do the problem. Okay. Are we comfortable with 16? Does that make sense now? Okay. I can almost guarantee there's going to be an FRQ on the AP exam that has a chunk of this in it. So we want to get to the point where on the FRQ or on the AP exam, that when they give us these questions, we go, oh, my comfort zone, let me get some points real quick. That's kind of our goal, is that by the time we get there, we feel like, yeah, I've got these questions down. Okay. All right, so let's get the other packet out, the chain rule with trig. Did it make you feel like this? No. That's a no for me, Ms. Riz. Okay. Okay, how did the first page go? These ones? Pretty solid. Did we need to go over any of these? No? Okay. So it was Verge doing a great job of coming up with some nice challenging problems that made you want to stab your eyeballs. Marvelous. Okay. Thank you, Verge. So it put you on the verge of stabbing your eyeball? No, okay. So which problem should we? The other thing is, so Reagan and I were working on this last period, and I realized when I did my answer key, I only wrote the answers. I did not do this assignment. Miss Rice, bless you. Bless you for that. Thank you. Marvelous. So I did not realize I did that either until I went to help Reagan, and I was like, I was helping her because I know how to do calculus. And then I was like, well, let's check my work. And I was like, oh, I literally never did this assignment. That was lazy of me. So let's do some of these together on the fly. That sounds wonderful. Doesn't that sound wonderful? Yes. So which one? And describe it as upper left, lower right. Describe it that way. Last one on there. Oh, yes, of course, this one. Okay, this is one where I think that I probably need to print your next resource sheet now, which is going to be all the trig identity stuff. The sheet that I pulled up yesterday but haven't printed yet. And I believe, I want to say that I printed that on blue paper. I think I referred to that at some point as the blue sheet, but I need to figure that out. So I will probably print that for you today. So yes, let's do that one. Let me get a fresh sheet of paper. And I probably owe you guys a legit answer key for this. Like, Miss Rice, I did not feel solidarity with the way that you made that quote-unquote answer key. All right.
Because otherwise I'd spend, I don't know, 40 minutes on problems trying to figure out what I did wrong. I tried that for like 2 of them.
Okay, so first thing I would do is take the problem and rewrite it. Some students can leave it as sine squared x and remember to do the chain rule and do it correctly, and I, for whatever reason, cannot see it like this and think through the chain rule without my brain just like shutting down. So I have to take this and rewrite it this way. I have to. Like, I have to. There's no other option for me. Okay, and I'm going to go ahead and do the quotient rule instead of rewriting it with the negative exponent. I know some of you guys are a little bit more comfortable with the product rule, but I'm going to go ahead and do the quotient rule. All right, so let's do, we've got low, d high, and what's the derivative of the top? This is prime. Negative sine x. Okay? Okay, low d high minus high, d low. All right, here's our chain rule. So when I do the derivative of the bottom, I've got 2, keep the inside the same, drop it by 1, times the derivative of the inside, which is cos. Marvelous. Okay, divided by the bottom squared. So we've got sine of x squared, and then that is being squared. Okay. All right, so what I can see is that we have a sine squared and a cos squared, but we do have an extra sign on top that's GCF. So I'm going to take that GCF, I'm going to move it to the front. Are we comfortable with that? I also have a negative, so this is like my first term right here. This is like my second term right here, and both of those terms are negative, so I'm also going to move my negative to the front with my GCF of sine. Are we comfortable with that? Okay, so I'm going to say y prime equals negative sine. So this, I moved this to the front for this first term. Here was my first term. And I moved this to the front, and that leaves me with the sine squared behind. Do you see what I did? Okay. Yep, so this is sine squared and sine. And I took this and moved it to the front, and then I left this behind. This is, altogether, this was sine cubed. So I took 1 out, and I'm leaving 2. There's not a plus here, it's a times. Okay, and then over here, I'm going to write plus now. I'm taking out this negative. I'm taking out this sign. I'm leaving behind a 2, and I'm leaving behind a cos squared. Comfortable with that? And then on the bottom, I have sine squared squared, which is sine to the what? 4th. So at this point, we can cancel one sign with one of these signs. So that's going to leave it to the third. Okay, this is where we're doing it on the fly because I don't actually... I'm going to have to look and see. We're going to look at our resource sheet and see what trig identity options we have. Okay, here's what we're going to do. We're going to do y prime equals negative sine squared x plus cos squared x plus cos squared x. We're going to split that cos into two pieces. Bear with me for just a second. Yeah, okay, what do you guys see? You kind of see? Okay, so what do you guys see? What's this? Yeah, and what does it equal? It's 1. Okay, so y prime equals negative 1 plus cos squared x. So what Miss Verge Cornelius was doing when she made this is she was trying to avoid having a fraction. She was thinking, if I can use those reciprocal identities, I cannot have a fraction in this problem. I can write this, instead of writing it in terms of cos and stuff, I could write it in terms of one of the reciprocal identities instead, and then it wouldn't be a fraction, and that would be nicer. And most of us are like, oh, please, let's just have a fraction. That sounds, I'm more comfortable with that. By all means, please. Yeah, okay. So let's go ahead and do this. Let's now split these into two pieces. So now I'm going to say y prime equals negative, and I'm going to say 1 over sine cubed plus cos squared over sine cubed. Are we okay with that? Okay. What is 1 over sine? Cosecant. Okay. So this is now negative cosecant cubed. Okay. Now with this one, I'm going to call this one cos squared over sine squared times 1 over sine. Are we comfortable with how I split that apart? Ms. Rice, this is a lot of work. Yes, you guys, I will probably go back and scribble out that answer on the worksheet and put this answer instead. I will do that for future classes because this is kind of atrocious. Did you guys go and look at the answer key online and at least cheat and move on to number 8? Did anyone do that? Marvelous! Yeah. So, okay, if this happens in the future, text me and be like, Ms. Rice, this problem is insane. Can I cheat and skip and go to number 8? And then I'll be like, why would you do that? And then if everybody in the class has texted me about it, I'll be like, oh my gosh, skip it, go to number 8, guys, please. You know what I'm saying? Like, if everybody had texted me and I'd realized this problem was atrocious, then I would have said to everybody, please do cheat, skip it, go to number 8. Yeah. Then I'd be like, whoa, skip those. Whoa, Miss Rice, how did you not know this? And then I would have realized I never actually made the answer key. Yeah, so, yeah, I'm not evil, you guys. Okay, so looking at the reciprocals, or just off the top of your head, what is cos over sine? Not tangent. Cotangent. It's cotangent. So this is cotangent squared times what? Cosecant. Okay, so this is negative cosecant cubed plus cotangent squared times cosecant. Okay, so then what did they do? Then they took out the GCF of cosecant, and that's how they got that answer. Miss Rice, doesn't that seem like overkill? Absolutely yes, I wholeheartedly agree with you. So, note to self, go back and fix this. But I think this also tells me that last year's students definitely skipped this problem and just didn't tell me. Because I used this assignment last year and nobody said a thing. So I think it's fair for us to say that this could have been the answer, though. Do you think this is fair? We all should have gotten here? Okay. I think this is fair. I think factoring out sine and getting here would have been reasonable. Okay, what's another problem that you guys did not feel comfortable with? Bottom left, first page. Okay, now I do think that one is reasonable. It's not fun, but I do think it is. I think this one was truly unreasonable. I really do. I think that one, maybe as a pre-calc challenge question, because pre-calc is when you did all the trig proofs. In calculus, I'm not feeling it, honestly. If she wanted you to evaluate this, I would have felt that, but as far as this, I think it's a little unnecessary. But number 6, I do think is a good question, and let's go ahead and go over it. So this is number 6, bottom left of the front page. 2x square root x squared plus 7. Okay. So we do have a chain rule. We can see it right here. We've got inside stuff. We have that exponent of 1/2. But we also have something in the front, something back here, which means we do have a product rule happening as well. Okay? So the first thing I'm going to do is I'm going to rewrite the problem with that exponent. So 2x x squared plus 7 to the 1/2. So talk me through the product rule. How do we start it? First, you can do the chain rule as you go. Yeah, so first times derivative of the second, and as we do the derivative of the second, we have to do the chain rule. So how do you do the chain rule of this? So derivative of the outside, which is 1/2. That's why I gave you the look. I was like, x, 1/2, 1/2. Okay, so 1/2 times, so it's 1/2 in the front, negative 1/2 on the outside. And then what do I put inside? X squared plus 7, keep it the same. Times derivative of the inside, which is 2x. Okay, so we did first times the derivative of the second plus second times the derivative of the first, which is 2. So the calculus of the problem is done. Now it's a cleanup. So 2 times 1/2, I'll just get rid of that. And then I've got x times 2x, 2x squared. And then I've got a negative exponent, so that's going to go on the bottom. And it's a radical. And then here's my second term. I've got a radical and a coefficient of 2. I'm going to go ahead and make this a fraction. I'm just going to put it over a 1, so I know it's a fraction. Now we know Virgie. She's not going to want to have 2 different fractions. No, she's going to want 1 fraction. We know Virgie. So how do we get this to be 1 fraction? Yeah, so we rationalize. Not quite conjugate, but same idea. So we're going to rationalize this or not rationalize, I lied. That's not what we call it. We're going to multiply by root x squared plus 7 over root x squared plus 7. So this is the denominator of the first fraction, and so we're just getting a common denominator. Okay. So this one's going to stay the same. And then now this one's going to have that common denominator, because I just did that intentionally. And what happens when I multiply a radical times the same radical? They cancel, and we just get what's underneath. So I get 2 parentheses x squared plus 7. So now I have that common denominator. And I have this 2x squared, and what do I have over here? So I got 4x squared. Okay. And then I have 2 times 7, which is 14. I do think that was a really good problem. I think that was pretty representative of, like, that is a regular calculus level difficulty. That was not over the top. That was pretty appropriate. This was like, ugh. What are we in? Pre-cal? No, I passed that class. Let me move on. Rude. Okay. Yes, the cube root x squared plus 7 times cos. Okay. Okay, so we're good on this? Okay, so we got the product rule again. We got one thing times another thing. I don't know that this one had much done other than the quotient rule. So I'm going to rewrite this, or not quotient rule, product rule. Sorry. Product rule with some cleanup. I'm going to rewrite this as x squared plus 7 to the 1/3 and cos x. Okay. All right. So let's start our product rule. First, which is plus and what's the derivative of the first? Okay. All right, so the calculus is not the hard part, the algebra is the hard part, okay? Now, this is a negative, that's going to move it to the bottom of the fraction. It's just like before, where the complicated part of this problem is getting that common denominator and cleaning it up. That's what made the answer look so crazy. So I'm going to go ahead and move this this negative to the front, and I'm going to put this back as a cube root. So, and I'll go ahead and put I don't know that it really matters where I put I'll maybe put the negative sign. I'm going to put the negative sign in the front of the cube root. So I'm just going to put negative sign x, and then I'm going to put cube root. Are you guys comfortable with this? How I'm writing it? X squared plus 7. Are we good with that? Okay.
Under that piece and whatever it's below. It can't go under if you're
Oh. I think I found the problem. Okay. And then here I've got a 2x and a cos x, and so that's going to go on top. And then the 1/3, that 1 multiplies by the stuff on top. And the 3 is moving to the bottom. And then the other thing that's moving to the bottom is the cube root of x squared plus 7. But that x squared plus 7 is squared. Okay. All right, now I'm going to pretend I don't know what the answer is. So I'm going to do this as though I didn't know. Okay? So I'm just going to say I need a common denominator. And my common denominator is going to be not just the cube root of this squared, but it's also going to be the 3. Okay, I can see that the final answer doesn't have the 3, but this has a 3, and if I didn't know what the final answer was before I started, I'd have the 3 in there. Okay, so something is clearly going to happen to cancel the 3 out since her answer doesn't have a 3 in it, right? Her answer doesn't have a 3 in it. At some point, that 3 is going to go away. So we're just going to see what happens, okay? Oh, you know what it is? She has that 2/3 x. She just left the 2/3 on top. Verge, you cheater. You guys see that? I just choked myself. I went like a second. I'm going to leave the 3 on bottom. Verge, I don't like this, ma'am. 2 fraction within a fraction. Ooh, I'm salty. Angry. All right, what do you guys think? Do you want to leave the 2/3 on top or do you want to put the 3 on bottom? I'm very salty at Verge right now. 3 at the bottom because it feels more right? 2/3 on top? Verge. Well, I'll be. Come on, Verge. Okay, so we're going to do, I'm putting this over 1, and I'm going to multiply top and bottom by 3 and cube root x squared plus 7 squared. Ms. Rice, why do you always write down all of your work? It gets tedious. Because I have found that if I don't, I get confused. Good answer? All right, so over here, what happens when I do something to the 2/3 multiplied by something to the 1/3? What happens to that exponent of 2/3 and 1/3? They add. 2/3 plus 1/3 is 1. So basically what happened to these radicals? They basically cancel. Do you guys see that? So normally if I had a square root and a square root, that would be a 1/2 and a 1/2 makes 1, and a square root and a square root cancel. Okay? A 1/3 and a 2/3 cancel. Does that blow your mind a little bit? Okay, but these cancel because their exponents add to 1. Okay, so what we have now is we have, I'm going to take the 3 and the negative, I'm going to put them together, -3 sine x, and then we just have an x squared plus 7 with no more radical, no more exponent because the 2/3 and the 1/3 added together to make a 1. So we technically have an exponent of 1, but nobody even writes the 1. Who writes the 1? Nobody. So I'm going to erase it because it's just silly. Okay. And then my denominator is the 3 and the cube root of x squared plus 7 squared. Okay. We are very close to what Virgie had. Do you feel better about calling her Virgie, like you're getting some of your power back? I feel better about it. Okay. Virgie, I'm sorry if you see this. We don't mean anything. And distribute. This problem was a little bit evil. It's the mixture of trig with non-trig. I think it would have been better to just commit to one or the other. It's a little bit evil. Okay. we got our common denominator. But we did learn something about radicals, so that was kind of nice that we did learn something. All right. What should I write for this first term? I did negative 3 sine x times x squared. How do you guys want to write that? Okay, negative 3 x squared sine x. I wouldn't write it any other way. That's how I would write it. I just wanted to make sure you guys felt good about writing it like that. I think any other way you wrote it, it would seem like the x squared was inside the sign. And so I think this is the perfect way to write it. Yeah. Don't worry, it's Helen Keller. Okay. And then what else do we write? Negative 21 sine x plus 2x cos x. So we have the same thing that Virgie had, but we do not have the fraction on the top. So we have the 2 of the 2/3, and then we have the 7 multiplied by 3, and we have the x squared multiplied by 3. So we have like the more proper version of her answer. Because we bumped the 3. Yeah, if you divided by 3, divided by 3, divided by 3, divided by 3, then you'd have her answer. Okay. We're on a roll. Do we need to do another one? Okay. This is good. I feel like I'm being tested, and I'm proving my worth as a calculus teacher, and I feel good about it. So.
Any of the ones that you have a problem with? Yeah, I don't know.
Okay, we have on the second page this one. I don't know which one you should.
Doesn't matter.
I started with the second one on the left, second on the top.
So do we want to do 18, 16, or 12? 18? Okay, so for this one it says, for what value of t does this have a horizontal tangent? For what value of t does this have a horizontal tangent? So before we even get started, what is our plan of action? This is number 18. It's on the second page, top left, second one down. So it says horizontal tangent. So when I read the word tangent, what do I think? Okay. When I read horizontal tangent, what do I think the derivative needs to equal? 0. So our plan of action is to find the derivative and set it equal to 0 and see what t equals. That's our plan of action. Okay. We do need to make sure that it doesn't equal 0 on the bottom and 0 on the top. It has to just equal 0 on the top when we do it. Okay? Because 0 on the bottom is what? Is undefined. Okay? So we have to make sure it's not a horizontal / vertical asymptote trying to happen at the same time. We got to make sure it's only 0 on the top. Okay. All right, so I'm going to rewrite this problem as 3t minus 2 to the 1/2 over t. And what rule are we using? Quotient rule and chain rule together. This is my favorite when they mix two. I love it. All right, so we got y prime. And what do we do? Low d high. So t times what? Okay, so I got 1/2, I got the negative 1/2. What do I put inside? 3t minus 2. Helen, leave us alone. Times. We thought it was another Helen Keller. We've had Helen Kellers up and down the hall, period, yeah. Hi. Good. All right, so the derivative of the inside is 3. This feels very official. Yeah. Oh, hi, hello. I'm very distracted right now. Okay. So low d high, and then what do we do? Minus high d low. And what's the derivative of the bottom? 1 divided by low squared. Right. You don't like my tape job?
No, I'm actually quite impressed, ma'am.
Oh, thank you. Would you like me to give training sessions on it? Because I can.
It would be better if you put
Not tape?
right, not tape. Tape can heat up the cords, but
Oh.
that's just a little piece. I'm sure you're probably fine.
Okay.
But I'm trying to think of the zip ties.
Oh, sure.
Zip that off.
That's fair. That's fair.
Thank you. Sorry for the
I keep track of all these cords. And if they catch on fire, I blow it out immediately. So, yeah, yes. I don't stomp it out. I yell at a kid and I make them come and stomp it out for me. So, I do it correctly. And don't worry, the lights that aren't on have already caught on fire, and so we don't use them anymore. Don't worry, Megan, I got it. You're welcome. You're welcome. Anytime. Anytime. Marvelous. Marvelous. With a raise. Okay. All right. They were making sure my classroom was up to code, so I wanted to help. Okay. They were commenting because I have cords back there that I taped. I was like, I saw them like, and I was like, yeah, I taped it around so that it wouldn't like be hanging. I don't know. Apparently they liked it, but zip ties are better. Got it. All right. What should we do to clean this up a little bit? Can we take this and move it to the bottom? No, because there's a subtraction right here. Oh. Oh. Okay. So we're gonna have this over t squared right here, but we are gonna have a fraction right here. Dang it, Virgie. Okay. So help me with this piece. Okay. There's never too many fractions. I love me some fractions. Okay, so the 1/2 is right here, 1/2. The t is right there, 3 is right there, this is right there. So the first piece is taken care of. And then this is just on top because it's positive. Okay. Now, we don't really have to do the piece where we get a common denominator because this is what we call a complex fraction. So if you remember from the summer assignment, I don't remember what section, but I said that we could multiply, kind of like getting a common denominator here, but instead of doing it right here, we're going to do it for the whole thing, and we're actually going to do it to get rid of the denominator right here. So we're going to do 2 square root 3t minus 2, 2 square root 3t minus 2. You'll see. You'll see what happens. Yeah, you'll see what happens.
But this way, because technically, like that 2 square root 3 minus 2 is over 1 being multiplied to the whole top, right?
Okay, so this, when you multiply it by this one, what happens? Cancels with the bottom. You see that? So we have a fraction multiplied by this. So we have 3t divided by this multiplied by this. And so it cancels and just leaves the 3t behind. Is that okay? Okay, now this one, we have the radical multiplied by 2. So I'm definitely going to have the 2, right? And then what happens when we multiply the two radicals together? They cancel and they leave just what is inside the radical, 3t minus 2. Okay, now when I multiply the bottom times the t squared, nothing cancels out, I just get the whole thing. So now I have 2t squared times the radical. Yeah, because this was, remember, it was the whole quotient thing, the whole thing on top over t squared. So then I had to multiply this by the top, but I also had to multiply it by the bottom. So I just multiplied it, and I just kind of put the front with the coefficient, the t squared with the coefficient in the front, and then... Okay, so let's clean up the top. We've got negative 6t plus 4. So y prime, my denominator's not changing at all. And then negative 6t plus 4. Miss Rice, can you reduce it by 2? Yes, but I don't even care about that. Who cares? Not even worried about it. Ah! Yes, I just wrote this. I forgot the 3 over there. So we have 3t plus negative 6t plus 4. And 3t plus negative 6 is the negative 3. Thank you for the correction. Okay. So we have successfully found our derivative. No, we're almost done. We're almost done. Because remember, what did we need to do? Make the derivative equal 0. And thank goodness that is only dealing with the top. Oh, thank goodness. Okay. So let's make the top equal 0, negative 3t plus 4 equals 0. Now, we do need to make sure that if we think about plugging this into the bottom, that it wouldn't make the bottom equal 0 as well. Because if it makes the top and the bottom equal 0, it's not actually a horizontal tangent. Okay? So if we plug it in here, it's going to remain positive, so that's not going to affect anything. If we plug it in here, 3 times 4/3 is just 4. 4 minus 2 is 2, not 0. Thank goodness. Okay, so we're good. Whew! Yeah, because I didn't do the problem. I didn't do the problem. Come on, man. We figured it out already. Miss Rice did not actually make an answer key. She copied the answers and called it good. Okay. No, she did not. She did not actually make an answer key. Okay. Do we want to do number 16? Yes. Okay. So this one is left column, second from the bottom. And we want r prime of -1. Okay. So this one is kind of set up for a quotient rule, but because the top is a number, it could be really good to not use the quotient rule if you just rewrote it. So do you guys want to do quotient rule? Do you want to rewrite? What do you think? Rewrite? Okay. So if you rewrite, you've got r of t is 3 t squared minus 2t to the -2. That's just rewriting it. Okay. So what do we do? chain rule. So negative 2 times 3, drop the exponent by 1. So what's the new exponent? Okay, multiply by the derivative. Okay, so I'm just going to clean it up a little bit. I'm going to do negative 6 times 2t minus 2, and I'm going to put that over t squared minus 2t to the third. And then I'm not going to worry about doing anything else. I'm just going to plug in the negative 1. Because it's a whole thing. And so if you don't, you'd just be multiplying by 2t and subtracting 2 off the end, and it's not. It's times the derivative of the inside. And 2t minus 2, the whole thing is the derivative of the inside. It's not times 2t and then subtract a little 2 off the end. Did anyone do the bottom left and feel good about it?
Which page?
This number 12, bottom left of the back page, and feel good about it? Yes, Michaela, will you go to the copy room and get our review for us? Thank you. All right, bottom left. No. Okay. So, now if you wanted to, we have two different ways we can do this. We can treat this one like this assignment and kind of work with it symbolically like this. Or we can rewrite the problem and kind of work with it like the rest of these have been. So how would you guys like to do it? You want to treat it like this worksheet? Or do you want to treat it like this? Treat it like this sheet? Okay. So what we're going to do is we're going to ignore the functions to start with, okay? So we're going to just ignore these, okay? Let's just look at h of g of x. What is, if this is f of x, then what is f prime of x? H prime, keep the inside the same, times g prime of x, okay? So we had our function, we took the derivative of our function, okay? So now if I want f prime of negative 1, I just need to go through and say, okay, h prime of g of negative 1 times g prime of negative 1, okay? So now what I'm going to do is I'm going to go back and I'm just going to look at what information I need and I'm going to find it as I need it. So right now I don't need h at all. All I need right now is g. So I'm going to find two pieces of information. I'm going to figure out what g of negative 1 is. not -3, not 3, 9. Here's a typo, don't worry about it. Okay, 9. And then I'm going to find what G prime is. And I'm going to find what G prime of -1 is. That's G prime of -1. Okay, so now I can say, okay, this is H prime of 9 times -12. Okay, see how I did that? All right, now this time they said, okay, you need H prime to be able to do the problem. So now I'm going to go, okay, so H of x, I'll do it over here. H of x is the square root of x, which is x to the 1/2. And so H prime of x is, okay, which we know is 1 over 2 square root x. So H prime of 9 is 1 over 2 square root 9. 1/6. So this is 1/6 times -12. -2. You probably did it the other way you can do it. Yeah. Yeah, you can do it both ways. Yeah, you can do it the other way too. So this way we dealt with the chain rule symbolically instead of dealing with the chain rule as an equation. Yeah. They're both right, right? You got the same answer. Yeah. Well, and that's kind of the point too, because we're at the point in math where it's not necessarily one approach is the perfect and right way to do it. You kind of, it's like, okay, which way do you want to go? And you start to learn, ooh, this method is a little bit easier in this situation, but maybe I should use this method in this situation. You start to figure out little tricks, and sometimes you try a method and you go, ooh, that was not the right one. That was not the helpful way to do it. You know, so it's at this level we start to realize, like, Ms. Rice, which way should I do it? And I go, well, there's a few different ways. How did you know? I've done a lot of these. And you start to get like an intuition for how to do it, and it's not something you can just tell someone. It's from doing lots of them. So, okay. Have we hit all the trouble spots? Marvelous. Okay. I am sorry that I tortured you last night. Yep.